Heat is the energy that is transferred from one body or system to another as a result of a temperature difference. The study of heat is known as thermodynamics, and it has several properties that are worth understanding. Here are some of the most important ones. Heat flows from hot to cold. Heat always flows from a body or system that has a higher temperature to one that has a lower temperature. This is known as the second law of thermodynamics. The direction of heat flow is determined by the temperature difference between the two bodies or systems. Heat transfer mechanisms. Heat can be transferred by three mechanisms: conduction, convection, and radiation. Conduction is the transfer of heat through a material or between two materials that are in contact. Convection is the transfer of heat through the motion of a fluid, such as air or water. Radiation is the transfer of heat through electromagnetic waves, such as infrared radiation. Specific heat capacity. The specific heat capacity of a material is the amount of heat required to raise the temperature of one unit of mass of the material by 1 degree Celsius. Different materials have different specific heat capacities, which means that they require different amounts of heat to raise their temperatures by the same amount. Heat and phase changes. Heat can also cause phase changes in materials, such as melting, boiling, and condensation. During these phase changes, the temperature of the material remains constant, even though heat is absorbed or released. Heat and work. Heat and work are two forms of energy that can be transferred between systems. In thermodynamics, heat and work are related by the first law of thermodynamics, which states that the change in the internal energy of a system is equal to the heat added to the system minus the work done by the system. Heat capacity. The heat capacity of a system is the amount of heat required to raise the temperature of the system by 1 degree Celsius. The heat capacity depends on the mass and specific heat capacity of the system. Thermal expansion. When a material is heated, its volume usually increases due to thermal expansion. The amount of expansion depends on the material and the temperature change. Heat and entropy. Entropy is a measure of the disorder or randomness of a system. The second law of thermodynamics states that the total entropy of a closed system can never decrease over time. Heat plays a crucial role in the increase of entropy, as it causes particles to move more rapidly and increases the number of possible states of the system. Heat engines. A heat engine is a device that converts thermal energy into mechanical energy. Examples include steam engines, gasoline engines, and turbines. Heat engines are based on the principles of thermodynamics, and their efficiency is limited by the second law of thermodynamics. Heat transfer and insulation. Heat transfer can be a problem in many applications, such as in building insulation, refrigeration, and electronics cooling. Understanding the properties of heat transfer, such as the thermal conductivity of materials, is important in designing effective insulation and cooling systems. Heat and temperature measurement. Temperature is a measure of the average kinetic energy of the particles in a material. Heat is the transfer of energy from one material to another due to a temperature difference. Temperature can be measured using various instruments, such as thermometers and thermocouples, while heat can be measured using calorimeters. Heat and phase diagrams. Phase diagrams are graphical representations of the relationships between temperature, pressure, and the phase of a material. Heat plays a crucial role in determining the phase transitions that occur in materials, such as melting, freezing, and sublimation. Understanding phase diagrams is important in materials science and engineering. Heat and chemical reactions. Heat is often involved in chemical reactions, either as a reactant or a product. Endothermic reactions absorb heat from the surroundings, while exothermic reactions release heat. Understanding the heat effects of chemical reactions is important in areas such as chemical engineering, pharmaceuticals, and environmental science. Heat capacity and temperature changes. The heat capacity of a system determines how much the temperature of the system will change in response to a given amount of heat. Systems with higher heat capacities require more heat to produce the same temperature change. This is important in designing heating and cooling systems, and in understanding the behavior of materials under different temperature conditions. Heat and pressure. Temperature changes can also cause changes in pressure, as particles in a material move more rapidly or more slowly. This is important in areas such as thermodynamics, fluid mechanics, and materials science. Heat and radiation. Heat can be transferred through radiation, such as infrared radiation, which is emitted by objects with a temperature above absolute zero. Understanding the properties of heat radiation is important in areas such as astrophysics, optics, and electronics. Overall, understanding the properties of heat is crucial in many areas of science and engineering. The study of thermodynamics, heat transfer mechanisms, and phase transitions helps to explain how energy is transferred and transformed in various systems, and how temperature, pressure, and other factors affect the behavior of materials.